Well, hey everybody. Today, what are we doing today? We are going to be doing some linear inequalities and compound inequalities, and then we're going to get to something that I found really challenging the other day and need to refresh my own knowledge base with regards to dimensional analysis and converting unit rates. So I'm going to put the timer up. We're going to get started here in just a few minutes. Lily, you can have a laugh if you go watch my stream from yesterday. I was working on the problems, and I remember had to do dimensional analysis just fine, but there are some that get really complicated when it comes to area and volume problems. So I made a few mistakes that I had to re-educate myself. So it's always fun when I get to engage in the learning process by learning from my own mistakes. All right, I'll be right back. All right, looks like we're going to give people another 3 minutes or so to join us for some all kinds of fun. Okay, well, this will be the first one we're going to try, and I guess we're going to give the masses, I'm sure we're going to get a massive influx of people in the next 30 seconds, but we'll give them their time. And that time is now over. Okay. So here we go. All right. So for those of you joining us on the replay on YouTube, what we're going to be doing today is talking about linear inequalities and dimensional analysis. Some of it can be pretty rigorous, so I'm hoping you guys are ready to go. At any time you want to work out a problem ahead of me, just pause the video and get your work done, and then check with me back after you hit resume. So here's where we're going to start. Solve for y. Reduce any fractions to lowest terms. Don't round your answers, and don't use mixed fractions. Okay, well, I guess the first thing we're trying to do here is just understand the problem. So we got our math practice standards going. So let's just make sense of what they're asking us to do. Okay, so we've got an inequality. The reason I'm calling it an inequality is because it has this symbol, not an equal sign. Okay, so I guess the first thing I would do on my own paper is just, write it down. So I've got 5y plus 3 is greater than negative 7y plus 13. Okay. Well, the first thing I would like to do is combine like terms if there were any, but I don't, on the left side of the inequality and on the right side of the inequality, there's no like terms to be combined. There are no sets of constants or coefficients with variables that go together. So, okay, that's fine. So we're going to treat this just like we would an equation and do some inverse operations. So we're going to be completely abusing math practice standard number 2, reasoning abstractly. And what I mean by that is these basically two things. Anything being combined with its opposite is going to result in an answer of 0. And then anything divided by itself is going to be equal to 1. And those are our two abstractions we use the most in algebra. So like in this case. The first thing I want to do is get all the y's on one side, and if you're like me and you want things to be positive as much as possible, I'm going to go ahead and add 7y to both sides. Hey RJ, good to see you. So we're going to add 7y to both sides, and then we're also, to get all the constants on the other side of the inequality, I'm going to subtract 3 from both sides. So where does that leave us? Okay. Well, according to our abstract rules, positive 3 minus 3 makes 0. So the math colloquialism is just they cancel each other out. Negative 7y plus 7y, they cancel each other out. So what we're left with, if you're curious, why I was doing it in that way, that's my own intuition based on how many problems I've done. So the more you practice, the more you'll understand how to do them better. Well, 5y plus 7y is 12y. This makes 0. The greater than symbol is still there. So 12y is greater than, this made 0. So 13 minus 3 is 10. Okay. So 5y and 7y is 12y. 13 minus 3 is 10. Okay. So then the next thing to do to get y by itself is just to divide both sides by 12. The reason we did that is the other abstract rule. Anything divided by itself is 1. So 12 being divided by 12 is 1. So we'll end up with basically 1y on this side, which is greater than, and 10 divided by, 10 divided by 12 isn't going to give us anything but a decimal. So it wants us to reduce the fractions that says so in the instructions. So 10 and 12 can both be divided by 2. So 10, but that'd be 5, 6. So 1y is greater than 5, 6. And to be honest, I am kind of lazy. I'm not even going to bother that one. So it's just y is greater than 5, 6. So if you were answering this on your lesson, what you would have to type in, and it gives you the tools to do this, you type in the letter y, you put in the greater than symbol, and 5, 6. Now this problem behaved exactly how an equation would, because we never had to do one of the two things that flip-flops our inequalities. So this is just sort of a little teachable moment here. There are two things that would cause an inequality to flip. If you ever multiply or divide by a negative number, that is when the inequality flips around. But in this case, it didn't happen. I guess if I were to show you this in a slightly different way, it's not letting me shrink that, sorry. So I know that this is the answer, but just to demo you what I'm talking about, let me select everything, come on. 1 second, I gotta pause, just 1 second. Okay, so, yeah. It would make more sense for me to unmute myself before I start talking. Okay, so to demo what happens in inequalities when you actually have to flip the symbols around, I'm gonna do this problem just a little bit differently. Okay, let me rewind. So we had this, I couldn't combine like terms. Let's just say that instead of me adding 7y to both sides, what if I had subtracted 5y from both sides? It's perfectly legal. There's nothing wrong with it. If we'd done that and if we had subtracted 13 from both sides, here's where we would have been. The inequality, hang on, let me change that color. Draw, go, color. Okay, so the inequality would be the same. 5 5y minus 5y makes 0. 13, I'm sorry, 3 minus 13 would be negative 10. And then negative 7y minus 5 would be negative 12y. And 13 minus 13, there's another 0, cancels each other out. Okay, so now the next step, if we had decided to do it this way, we would have to divide by negative 12 to get y by itself, both sides. So this is where this rule kicks in. If you ever divide or multiply by a negative value in an inequality, the inequality flips around. So negative 12 divided by negative 12, that's 1y, I get it. But that also means, so yeah, this is going to be 1y, but I need to flip this symbol and point it this way. Negative 10 divided by negative 12. Well, negative divided by negative is positive, and 10 12 reduces the same way we had done it before into 5 6. But because the 5 6 is on the left side and the y is on the right side, I can get rid of that 1. The symbol has to be flipped around to make it equivalent to the other answer we have. So in both cases, y is bigger than 5 6. It's just written in 2 different ways. So the golden rule of inequalities is this. If you ever multiply or divide by a negative value, no matter what the negative value is, negative 2, negative 7, negative 100, doesn't matter, you must flip the inequality around to face the other direction. And that might not come up for many of you depending on your inverse operation choices, but when it does, that's how it works. Let's try. Actually, you know what I should do? I should check my email and see if anyone had a specific question. Screenshot it for me. 1 second. And that is a negative. Nope, nothing yet. Okay. So going back to another problem. Okay, so for the record, that particular problem I just posted, 9 students got that one in their practice, and only 3 got it right. So definitely one we needed to go over. So let's clear all this out. Let's try another one. So here's one where more students missed it than got it right. It's going to sound the exact same as one we just did. Here it is. Solve for W. Reduce any fractions to the lowest terms. Don't round your answers and don't use mixed fractions. Okay. 53W plus 13 is less than 56W plus 16. Okay, so I guess I'm going to do this 2 different ways. I'm going to do this in a way where I have to flip the symbol around, and I'm also going to do it in a way where I will not have to flip the symbol around. And it really does come down to choice. So let me type this out twice. So this is what you'd write down in your own paper. So 53W, that's the next. 53W plus 13 is less than 56W plus 16. I wonder. It will let me copy and paste. It's all right. 53W plus 13 is less than 56W plus 16. Okay. So I'm going to do this twice, and in one version, I'm going to have to flip the symbol around, and then one I will not. So let's go ahead and start. Chat, do you care which one I start with? Should I do the flippy first or the non? I think I probably should start with the one where it flips around. Okay, so the first thing I want to do is find out if I can combine any like terms, and I can't. 53W plus 13, 56W plus 16, neither one of them has common terms that can be combined. So what do I do? Okay, well, if I were to, say, subtract 56W from both sides, If I were to subtract 56W from both sides, what I'd end up with is negative 3W on this side. And of course, if I were to subtract 13 from both sides, I'd end up with 3 over here. Now the cancels. So 13 minus 13 makes 0, and 56W minus 56W makes 0. So here's where I end up. Negative 3W is less than 3. So the next thing I've got to do is divide by negative 3. And as soon as I do that, the moment I divide by negative 3, that's what causes this to flip. So now what I'm going to end up with, negative 3 divided by negative 3, that's going to be 1, so that's going to be just W. And then I have to flip this to greater than, and 3 divided by negative 3 is negative 1. So W is greater than negative 1. So that's the first way we can write that. Ta-da. So that's when you do have to flip the symbol. Now, watch how sometimes another student might solve this exact same problem and not have to do any flipping. Okay, so, like, okay, if I had done, so basically it comes down to this moment of truth where instead of me subtracting 56W from both sides, if I had subtracted 53W from both sides, which is completely allowable, I wrote an X here, it should have been a W. Okay, and then I would, let's see, what would happen if I did that? So the inequalities here, 53 minus 53 is nothing. So 56W minus 53W would be 3W. And then I could subtract 16 from both sides to get this to cancel out. 13 minus 16 would be negative 3. So now that negative 3 is less than 3W. So when I divide by 3 on both sides, I'm not dividing by a negative, so the symbol is not going to flip. I'm answering chat. It's just a pattern that mathematicians notice always works. So what we end up here with, okay, so since 3 divided by 3 is equal to 1, so we get 1W on this side of the inequality. Negative 3 divided by 3 is still negative 1. And I'm so lazy, I'm not even going to bother writing that 1. So notice these two things. I've just done the problem two different ways, and I ended up with negative 1 is less than W. Now, if you look at the two number sentences over here for my two answers, they are the exact same thing. They're just written in opposite directions. So W is greater than negative 1. Negative 1 is less than W. Those mean the exact same thing. So really, either way would be considered correct. But the only reason they both end up correct is this one little rule that I had to follow in the top. Let me see if I can highlight it for you real quick. Right here. So the moment you divide or multiply by a negative value when you're dealing with inequalities, your symbol has to flip around. That's all you have to remember. Whenever your inequalities are being multiplied or divided by a negative value, flip the symbol around and everything works out just fine. It's just one of those quirks that they notice, the mathematicians notice always comes out true. And this is why. But of course, there are choices. Depending on how you work the problem would depend on whether or not you do anything that merits flipping the symbol sometimes. So really, you just have to keep an eye out for it. That's all. Okay. So let's move on to something slightly different. So that's multi-step linear inequalities. Now the next one it's called compound inequalities. So check this out. This is a question that 6 students have tried and 0 have gotten it correct. Let's see if we can figure out why. So this is compound inequalities where they give us 2 and we're going to have to solve 2 and see what's what. Okay. So let's go ahead, chat. Let's go ahead and take this first problem over here. This first inequality. Let's go ahead and work with this one first. So on my paper, I'm going to write down 11x plus 4 is less than 15. Okay. So if I were to work this out, what would happen? Well, I would take away, let me change my color. I would take away 4 from both sides, and I would end up with 11x is less than 11 because these two things cancel each other out. And then I would divide both sides by 11 and end up with x is less than 1. Because anything divided by itself is 1, so 1x. Yeah, okay. So really what this one is saying is that x is less than 1. So I like that. X is less than 1. Okay, cool. So we've just proven that much. So now what we'll do is we'll take this other side, this one, and figure it out as best we can. So I'm going to go ahead and write it down as 12x minus 7 is greater than negative 25. So, okay. So I guess what I would end up doing is I would just add 7 to both sides. That way I'd still have this 12x, but since positive 7 and negative 7 are opposites, they cancel. So 12x is greater than negative 25 plus 7 would be negative 18. Okay. So next step-a-roo, if I divide both sides by 12, that's going to get x by itself because 12 divided by 12 is equal to 1. And having 1x is the same as just having x. I'm not flipping anything because I haven't divided or multiplied by anything negative. Now, negative 18 divided by 12, well, they both be, it can simplify by 6. So if I divide both top and bottom by 6, that would be negative 3 halves, negative 3 over 2. 1x is the same as x. So, okay. So that means that x is greater than negative 3 halves, negative 1.5, basically. X is greater than negative. So yeah, I agree with this one as well. So now we're looking at these other three options. So what is this A saying? A is saying that X is less than 1, which so this part right here, do we agree? I think we agree on that. X is less than 1. That's what that says. And we agree with that. And this other part is saying that X is bigger than -3/2. So right now it looks like A is the correct answer. A is less than 1, but it's bigger than -3/2. So essentially, if we were to draw this like on a number line, and out here is 1, here's 0, and over here is -3/2. I always have trouble with 2's. There we go. Okay, so if we had to graph this, we'd say that it's less than 1, so these are not equals to. So we open circle at 1, and we would say it's bigger than -3/2. So basically, all this room in between is our answer. So yeah, I would say the answer is A for this one. And out of the 6 students that got this one, nobody got it right. Yeah, great job, Lily. Yeah, I agree. A is the right answer here because they're both correct. And if you're curious as to how like none of them work or all of them would work, sometimes you'll get answers like just a quick teachable moment. So when you get all, that would be something like, let's say that if X was less than 10 and X was, or less than or equal to 10, or X was, let's see, it has to be an or X was greater than or equal to, I don't know, like -5, that'd be all numbers. It'd be all numbers going this way. It'd be all numbers going this way. It'd have to have an or in the middle though. Anyway, so it's possible. Let's try another one. For those of you watching on the replay, because I know you're watching this on the replay, you wouldn't skip the stream and not watch on the replay. The assignments this week are really rigorous, and what you got to do is just persevere and get through them and send me screenshots. If you come across a problem where it's just bonkers and you have no idea what to do, please snap a screenshot, email it to me so I can go over it on the next stream. All right, here's another one where 5 students were assigned this problem and 5 students missed it. Now, these might be the same 5 people that missed the last one, but who knows? Okay, so I forgot to go through my math practice standards. So basically, let's see. So step 1, let's go ahead and make sense of the problem and then persevere in solving it. So, by the way, that last one was an and, right? Oh, goodness gracious, Lily, we got to back up. Hang on a second. One little word might have changed that last problem. Let's go back to that last one. I got to recapture it. The word or and the word and can really make an impact on the answers for these. So let's just double check and make sure that we agree with our answer after. Okay. So hang on. This said, okay, I know we've already done all the scrap work for this, so let's just cut to it. This one is this side comes out to be X is less than 1, I believe. And this is the side that comes out to say that X is greater than -3/2. Okay. But the clincher here, I'm glad I started talking about it, made my memory go back, is the word or. You see, the problem with A being the answer, and I bet maybe this is why 6 people missed it. The reason A, I have a problem with it, is that what this is really saying is that this is an and answer. Like x is less than 1 and x is greater than -3 halves. That's what that's saying. X is greater than 1. I'm sorry, x is less than 1 and x is greater than -3/2. That is not what the problem said. So yes, we saw that this was true because of this inequality. And I'm sorry, the other way around. We saw these are both true because these inequalities do come out, but the word or is a big, where are my little symbols? The word or is really going to make the difference here. So because it says or, that means that our number line, which is here, so basically we're going to have one line so we say that x is greater than, so we have one number sentence saying that x is greater than -3 halves. And then we have another sentence that says that x is less than 1. Well, because it says or and not and, that means that the actual answer is going to be all real values, because once those two lines are going in opposite directions, we're talking about every single real number value will work for both, and real work for the system. Yeah, that one little word really changed it. Yep. Glad I reviewed that word. It's strange that the word and the word or are big vocab words for math, but they are. So what did we do in that problem? We had to construct a viable argument. Like we had to prove our own reasoning basically, and that's what we just did. Is going back and saying, hey, wait a minute, I'm not really sure about that answer. Let me go ahead and construct an argument that proves that I know what's what. We had to attend to precision, obviously. So yeah, really, really, really close call there. Let's curl these drawings in. Now let's go to that other problem that 5 people got wrong, because it is an and problem. Okay, this is not the exact same one I clipped. It's got to be really similar because it's 5 people missed it, and it's an and. 1 second. Almost didn't capture the whole thing. All right, here it is. So on the left side, okay, well, first I guess we should just automatically nail down that this is an and problem. It means it has to satisfy both inequalities. It's very inclusive. So, or it excludes all their answers, sorry. It's just what satisfies both. So let's talk about the left side. So I'm going to write it down. So it says -8x plus 3 is greater than or equal to 27. And I have to manually write in my underline here. All right, -8x plus 3 is greater than or equal to 27. So if I'm going to solve that really quickly, I would subtract 3 from both sides, and I'd have negative 8x is greater than or equal to 24, because those made it 0. So then I would divide both sides by negative 8. Now, because I'm dividing by a negative 8, I have to flip the inequality. So what I end up with, negative 8 divided by negative 8 is a whole number. It's going to be 1. So I have 1x over here. I have to flip the symbol to point the opposite direction. 24 divided by negative 8 is negative 3. And of course, I'm lazy, so I'm not going to bother with that 1 right there. Okay, so apparently for this one, x is less than or equal to negative 3. So that's part of the and clause. You might notice that's right here. X is less than or equal to negative. So I see that. Okay, check. So let's try this again. So with the other side, so negative 13 x plus 5 is greater than or equal to 57. Okay, so negative 13x plus 5 is greater than or equal to 57. Okay, so if we subtract 5 from both sides, we end up with negative 13x is greater than or equal to 57 minus 5 is 52. Okay, so now we need to divide both sides by negative 13. And the moment we do that, that's going to flip our symbol. So negative 13 divided by negative 13 is just going to be 1. So what do we end up with? Let me change colors just a smidge. So I'm going to end up with 1x. And now I flip the symbol, so it goes the other way, is less than or equal to 52 divided by negative 13. It's going to be negative 4, I believe. 13 times 4 would be 40 and 12. Yep, that's it. Okay, negative 4. Now, I'm lazy, so this 1 doesn't need to be there. So x is less than or equal to negative 4. So I get that. Yep, that's there. Okay, now, so here is the debate. Which of these answers makes sense? Because if we have a number line, let's go back to that. We have a number line, okay. And we have a point at negative 4. We have a point at negative 3. And we're saying that x is less than or equal to negative 3. And x is less than or equal to negative 4. Huh. Okay. So why is C wrong? I think I can spot it. This part right here is not correct because that's saying x is greater than or equal to negative 4. So that can't be right. And it's not that there's no solutions. So the question is, I'm pretty sure the answer is going to be E, because if x can be anything that's less than negative 3, No, it can't be all values of x. Okay, well, it's not that there's no solutions. And we can't say all values of x because what about these guys up here? What about everything that's greater than -3? So that doesn't work either. So you know what the answer is? It's got to be the pink. It's got to be B. Here, wait, let me get that back. Change color. It's got to be B, and here's why. When you say that x is less than or equal to -3, that's going to include all of that stuff. If you say that x is less than or equal to -3, that will include x is less than or equal to -4. Mm-hmm. Because it said both. It said and. It's got to be both of them. So I'd say B is the best answer there. The answer is saying x is less than -4. Oh, okay. Let me back that up. Something I just said. Where is it both? Hang on. Something I said did make sense, and something I said did not make sense. Let me back that up. Let me back that up. I gave you the or answer and answer. Where is it both? Okay. I'm going to draw these lines, but not on top of each other. And this makes way more sense. Okay, so the pink line, x is less than or equal to -3. None of our calculations are wrong. The very last second. And then we said these two things. Okay. So when it comes to the word and, we need to have both satisfied. So the question is, where on this number line are both things being satisfied? And the answer is right here. That's where both the lines are. So that's why the answer is actually A. I was giving an or answer, but I forgot, again, it's an and question. So when it comes to and, they are both satisfied as long as we're below and equal to -4. So that's your answer. I'm absolutely sure this time. Yeah, I've got to keep checking on that and or verbiage. That really makes a huge difference. Checking my inbox, see if anybody sent me a screenshot. Nope, nothing yet. All right. Well, we are going to move on. Now, this skill, I love it because it's so rigorous on the brain. It's a really great mental workout. We're going to start doing rate conversion, and the skill we're going to be using is called dimensional analysis. And if you want to go back and watch yesterday's stream, I made a few boo-boos that I had to fix. But that was really fun because learning on the job is kind of a little bonus to being an educator. So I remember the skill. I was just making mistakes with regards to area and volume because those units get really big really fast. So let's see if we get one of those today. So step one, let's go ahead and make sense of the problem. And then we'll persevere in solving it. A pitcher's arm rotates at a speed of 7 degrees per millisecond. At what speed does the pitcher's arm rotate? Oh, I did this one on yesterday's stream, so if you guys don't mind being patient, I'm going to grab a different problem. So for people that are watching multiple streams, I don't want to do the same problems over and over again. Here's a good one. Okay. Boulan rose on a crew team. Her team rows their boat at a split rate of 2 minutes per every 500 meters. What is Boulin's team rowing a rate at meters per minute? Okay. So dimensional analysis. The first thing you are always going to do is draw a line, just like this, right across your paper. Okay. Step 2, write down what you know. So what I know is that every 2 minutes, this person rows 500 meters. Okay, and we want to get this into meters per minute. Huh. That's strange that they flip-flop that, because in the top, it's minutes on top and meters on bottom. And they want to invert that? I guess that's just as simple as saying, well, I mean, if we just flipped them over, I think that'd be completely satisfactory. Oh, no, duh. It says 2 minutes, and this is an implied 1 minute. Okay, so we put the meters on top and the minutes on bottom. Easy enough. And then 2 minutes. If we just want to, oh man, I don't even think we need dimensional analysis for this. Here, let me grab all this and let me stop. It's just that's making it way too complicated. If we can keep it simple, let's do so. Okay, so they want this to be in meters per minute. So this is written as it's a proportion. It's a part-to-part proportion, so we can just rewrite this as 500 meters every 2 minutes. And they just want this to be reduced to 1 minute. That's really all that's asking for. So if we just divide by 2 on top and bottom, we'll get to 1 minute. 2 divided by 2 is 1, and 500 divided by 2 would be 250. So yeah, that'd just be 250 meters per minute. Yeah, I was making that too complicated by getting into dimensional analysis. We'll get to that, but not for that problem. Let me pick a different one that I did not do on yesterday's stream. This one will be a fun challenge. Okay. I don't believe I did this one on stream, and if I did, I'm apologizing now, but I don't think I did this one yesterday. I think I'd remember it. Okay. So first, let's go ahead and make sense of what it's asking us to do. Math practice number 1. Okay, so Mia paints interior walls at a rate of 12 meters squared per hour. Okay. At what rate does Mia paint in centimeters squared per minute? Ha. I'm definitely drawing a line for this one. Okay. But we've got to be super duper careful on this because it has squared units. So let's just go ahead and write down what we know for now. Right now we know that she's doing 12 meters squared every 1 hour. And then draw a vertical line. Okay. We know that to be true. The hour part is pretty easy to fix because 1 hour is equal to 60 minutes. So I'm done with those units. Okay, so I've got the minutes. I've done that. Now here's the tricky part. Converting from meters squared to centimeters squared is really, it's really sticky. So what we got to do is think about, okay, what do we get? What is 1 meter squared in centimeters squared? That's the question. I might need to spread that out a little bit. That's the question. What is the conversion between meter squared and centimeter squared? Okay, so here's the side math this is what I had to teach myself to do yesterday. So 1 meter is equal to 100 centimeters. So if we were to square both sides, if we were to square everything, right? So that'd be 1 meter squared. 1 times 1 is still 1. But this is going to be 100 times 100. So that'd be 10,000 centimeters squared. Yep, 1 meter squared is equal to 10,000. That's 4 zeros. 10,000 centimeters squared. Because 1 times 1 is 1, but 100 times 100 is 10,000. So 12 meters squared per hour. Well, 1 hour is 60 minutes. So I've got that unit down. And then we just got rid of meters squared. We have centimeters squared, so that's what we wanted. So now we got centimeters squared on top, minutes on bottom. So we should be good to go. Let's just grab our trusty calculator. See what this says. Okay, so that'd be 12 divided by 60 times 10,000. The answer is 2,000, and that is the correct answer. Sweet, 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 sweet. That makes me feel super good because yesterday that kind of problem was giving me a bit of a headache. So that's 2,000 centimeters squared per minute. And that's what I'm telling you guys. If you're watching this on the replay, you've got to bring me questions to do. And some of you are really worried you're not going to do well this week because I haven't seen anyone show up for Zoom sessions, whether in the morning or in the afternoon. But I'm hoping you're all watching it at home right now and making me sound like I don't know what I'm talking about. Okay. Well, I think I'm going to do one more and wait for you guys to send me some response and see where we go from here. Let's go ahead and pick a different one because most of these, like everyone's getting them wrong. Everyone's getting them wrong. I don't let you guys get the exact same problems, but it's pretty obvious you guys need more practice. You need help. You need to watch these clips. You need to come and ask me questions. Okay. I might have done that one. Okay, I'm absolutely sure I did not do this one because I don't remember the units. I don't recognize these units. So here we go. Okay, let's start by just making sense of the problem. Lucia is using energy at a rate of 420 kilocalories per hour ice skating. At what rate is Lucia using energy in calories per minute? Okay. There's a lot to unpack there because these units are really strange. So 420 kilocalories per hour, and we want it to be in calories per minute. Okay, well, the first thing I'm going to do is draw a line. Second step, I'm going to write down what I know. $420 kilocalories for every 1 hour. Well, the time part's really easy because 1 hour is equal to 60 minutes. And if you're wondering why I'm doing minutes on bottom and hours on top, basically, you got to imagine this like a fraction where we're trying to cancel units out. So as long as I have an hours on the bottom and an hours on top, those units are now negated. So I've now achieved that I've got minutes in the denominator. Okay. So now I'm going to end up with minutes in the denominator, but that doesn't really help me out with this numerator part. 420 kcalories. I'm assuming based on my understanding of metrics, that means 1,000 calories. I'm going to double check. Yep. A kilocalorie is 1,000 calories, like I assumed. Okay, just making sure. So I guess we're saying that's 420,000 calories? Say what? Lucy is using energy at a rate of 420 kilocalories per hour. Man, part of me thinks that is impossible. But we're going to check the answer here in a second, just see if 420,000 calories. I don't, like, if I go on the elliptical for, it takes me about 45 minutes to burn 1,000 calories. 420, this can't be right. 420,000 calories? So this is me trying to construct an argument. Lucia is using energy at a rate of 420 kcalories per hour. Okay, so I'm going to go ahead and solve this the way it is, and I'm going to take my real life knowledge out of this because I'm assuming there's something bonkers the way this is worded. But you know what? I might prove myself right. I might prove myself wrong. Let's just see what happens. So apparently, 420 kcalories would be 420,000 calories. Okay, sure problem. So where would I put this in my dimensional analysis? So 1 kcal is 1,000 calories. So units are going to cancel out here and here. So I'm left with calories on top and minutes on bottom. Okay. Well, let's see what happens. Something tells me it's going to be an outstanding number, but we'll find out. All right, so let's do 420 divided by 60 times 1,000. 7,000 calories a minute. Sure, that's possible. I'm hoping I'm wrong. I'm hoping and hoping and hoping that I've done something wrong that I can learn from a mistake. Because otherwise, ice skating is apparently the most beneficial exercise ever. Let's see. Nope, that's the answer. 7,000 calories a minute. My, okay. Okay, so let me just say this, person who wrote this problem. I think you're off by a decimal somewhere. I think you're off by multiple decimals somewhere, but the math checks out. I know that the dimensional analysis here is correct. I know that it's telling me that this ice skater is burning 7,000 calories a minute. I don't believe that for a second, but the math is correct. That I know. Okay, I can't end the stream on something I think is that absurd. So let me see if I can find. Yeah, here's another one, and then we'll call it a day. Seventh, man, I gotta become an ice skater for sure. If I want to slim down, ice skating seems to be the way to go now. 7,000 calories a minute. I don't know if Lucia is skating with a hippopotamus on her back or something. Maybe that's why she's burning so much. Who knows? Okay. Speaking of hippo, I need to catch up on more Midsummer Night's Dream, eighth graders. I've finished Act 1, Scene 1, but I got to get back to it and figure out what. And I've apparently Hippolyta or Hippolyta, however I'm saying it, I'm probably saying it wrong. But if you're not up to date, I think you should check and make sure what Miss Elliott needs you guys to have read. All right, so we'll call this the last problem of the day for sure. All right, so let's go ahead and make sense of the problem. The water pressure on Mustafa as he dives is increasing at a rate of 992,000 atmospheres per minute. Okay, so when he says the context of this word dives, meaning it's either scuba or free diving, but this is a person diving underwater. And as bubbles. Okay, so Mustafa's diving, and the atmospheric pressure is increasing because of the weight of the water above him. What is the rate of increase in water pressures at atmospheres per kilometer? Okay, let's write down what we know. Let's draw a line and write down what we know. Okay, so we know. Okay, it's 0.992 atmospheres. And by the way, guys watching the replay, do not panic when you see units you're not familiar with. Just stick to the problem, persevere, don't give up just because you've never measured in atmospheres before. Per 1 meter. And it wants this converted. So lucky us, the atmospheres part's already done. We already have atmospheres in the top. We just need there to be kilometers in the bottom. So 1,000 meters is the same as 1 kilometer. And the reason I have meters on top and kilometers on bottom is because I need these units to cancel out. So, okay. I've got kilometers on bottom. I have atmospheres on top. I should be good to go with the calculator. And we don't have an ice skater burning off 7,000 calories a minute, so I think I can believe this one. Okay, so what is 992 thousandths times 1,000? Oh, I could have done that in my head. Silly me. So 992 atmospheres per kilometer is the correct answer. So that's the amount of pressure he's gaining. I mean, it doesn't change. It's the same, but we're looking at it with different units. So that's dimensional analysis to keep track of your units and making sure your conversions are correct. I'm hoping you guys are watching these streams. I'm hoping you're coming up with questions because I'm looking at some of your work and your grades. I mean, your scores are lower than they should be, and I know you can do this. So try to join me on stream. Definitely watch the replays. I'm sending out all kinds of reminders for your parents to pass along to you, but you got to take some responsibility and get this work done, and not just get it done as in turned in, get it done at a high success rate. You are brilliant people. I know you can do this, but because we're not in the classroom, some of you, I think, are just letting yourselves like slump into these, low expectation modes. So please contact me if you need help, and I'll see you next time.